Hello. So today we're just going to go ahead with probabilities onto the next concept of probabilities called dependent versus independent events. Now, when this happens when there are two events, one right after the other, when there is a second event, not just one event, not just picking one flower out of the garden, but picking one flower out of the garden and then picking a second flower out of the garden. So when there is a second event, the second event is called either dependent or an independent event, and it's dependent or independent compared to the first event. So what's a second event? When there's a second selection, when you have two selections to find the probabilities for. These are also called a compound event. When you have two selections, you need to find the probabilities for instead of just one. That's called a compound event. And a compound event is either dependent or independent. So when you have two selections to find the probabilities for, good examples of this are when you roll a die and get a 3, and then you roll another die and you get a 5. Or you're being dealt two kings, the dealer is dealing two cards to you, they deal you a king and then they deal you another king. Or they deal you one card and then they deal you a second card from a deck of cards. So both of those examples have two selections going on with them, and they're called compound events. And these compound events are either independent or dependent. So what are dependent and independent events? An independent event, the second selection, the probability of the second selection, it doesn't matter what happened in the first selection during the first event. The second selection's probability is unchanged by whatever happened the first time around. A dependent event, the dependent event's probability, it depends on what happened the first time around. So what happens the first time around affects what's going to happen the second time around. And so that's called a dependent event. So let's look at some examples of an independent event. An independent event's probability, it doesn't matter what happened in the first event. So for example, you roll a die and you get a 3. Then you roll the die again and you get a 5. Well, it doesn't matter what you roll the first time around that you rolled a die and got a 3. That has nothing to do with rolling the die again and getting a 5. Now a dependent event, that dependent event, remember, the second time around, it's affected by the first time around. The first time around, the first selection affects what's going to happen the second time around. So for example, you're getting dealt a hand of cards and the dealer deals you a king, and then the dealer deals you another card. That second card is going to depend on what you got the first time around. Why is that? Because the first time around you had a fresh deck of cards, 52 cards, and you were dealt a king. So now you're holding one of the cards in your hand. You're holding a king in your hand. So when the dealer deals you another card from that deck, there's one less card out of the deck that affects the probability, and there's one less king out of the deck that affects the probability. So let's look at these. You'll figure out, you'll see this a lot more clearly once we figure out some examples. Let's do some examples. One is rolling a die and getting a 5 after rolling a die and getting a 3. So is this a dependent or an independent event? Well, let's look. The first thing you do is you roll a die and get a 3. So if there are 6 sides to the die, let's make our probability fraction like we learned in the first video. If there are 6 sides, total sides to a die, we're going to put that on the bottom of the fraction bar. So 6 total sides to a die. You could get any one of 6 numbers. And you got a 3 when you rolled that die. Well, there's only one 3 in that selection. In the numbers 1 through 6, there's only one 3 possible. So there's only one possibility of getting a 3 out of those 6 sides. So that probability is 1 out of 6. Then the second time around, you roll a die and you get a 5. Now the second time around, you roll that die, and let's do our fraction for this. You roll the die and there are 6 sides to the die. So let's put 6 on the bottom of the fraction. There's 6 total possibilities for rolling that die, and you roll a 5. Well, there's only one 5 on those sides of the die, so you have one chance out of 6 to get a 5 when you roll that's die for the second time. Now, do you see how both of these are the same? They both have 6 as the total possibilities. They both have 6 as the total possibilities. So therefore, these are independent. They don't affect each other. This second 6 is not changed by the outcome of the first 6. So these are independent. Independent. Now let's look at another example. Is this dependent or independent? Being dealt another king after being dealt the first king from the same deck of cards. Now the key here is the same deck of cards. So the first time around, you're dealt a king. You're dealt the first king the first time around. So let's draw our fraction, our probability fraction. Here's the fraction bar. Now, out of that fresh deck of cards, there are 52 cards in a deck of cards, right? So there's 52 possibilities. So the 52 is going to go on the bottom of the fraction. There's 52 total possibilities. You can get one out of 52 cards when you're being dealt a card from a new deck. And if you want to get dealt a king, there are 4 kings in that deck of cards, right? So 4 goes on top. So you have a chance of 4 out of 52 to be dealt that king. Now, let's say you did get dealt that king. You were dealt one card out of the deck, and you were dealt a king. Well, now you go to get dealt another card. Is that going to be dependent or independent? Well, the second time around, when you're getting dealt a card out of that deck, there aren't 52 cards anymore total possibilities. There are only 51 cards, because remember, you're holding one of the cards in your hand, that first king. So there's only 51 cards now available to choose from. And you want to get dealt a king. Well, how many kings are possible in that deck? Now there's only 3 kings possible in that deck because you were already dealt one of the kings. You're holding it in your hand. So the second time around, getting dealt a king out of that deck of cards, there's only a 3 out of 51 chance that you'll get dealt a king. So do you see how the first round, the first selection, getting a king out of a deck of cards, that affects this second selection? That if this 51 is different from the 52, it was changed by the fact that you already got a card out of the deck. And this 3 up here, 3 possibilities of getting a king, that was changed because you were dealt a king the first time around. So this second selection here, this second event, this is affected by the first event. This is changed. So it depends on what happens the first time around, what's going to happen the second time around. So this is dependent. Let's do another one. Being dealt another king after being dealt a king from a different deck of cards. Now this sounds a lot like the one we just did, doesn't it? But the key words here are from a different deck of cards. So you're going to have a new deck of cards both times. So let's do the probability fractions for these and look at it and see if they're independent or dependent. The first time you are dealt a king out of a deck of cards, a total amount of cards available is 52. And how many kings are possible to get dealt out of that deck of cards? 4. There's 4 possibilities of kings out of the deck of cards. So that's your first probability. Your first probability is 4 out of 52 to get a king out of a deck of cards. Now the second probability is out of a different deck of cards. You are holding the king from that first deck of cards, but when you're getting dealt a second deck or a second king, it's out of a new deck of cards. So the brand new deck of cards has 52 in it. And if it's a brand new deck of cards, that brand new deck of cards also has 4 kings in it. So you have a 4 out of 52 chance of getting dealt a king from a new deck of cards. Now, are these different? Does this second chance, is this second chance altered or changed at all by the first round, the first selection? No, it is not, because we're dealing with a brand new deck of cards. So the chances are still out of 52 possibilities, and the chances of getting a king are still 4 in 52. So since that didn't change, since the first dealing didn't change the second one, it's going to be independent. They're independent from each other. They don't affect one another. Let's try another one. Picking a rose from the garden after picking a daisy from the same garden. Now, if you remember from our first video, we had 12 flowers in the garden. So that's 12 possibilities total. And we had 4 daisies in that garden. So picking a daisy from that garden gives you a 4 out of 12 chance that you're going to get a daisy. If you go to just close your eyes and grab any flower out of the garden, you have a 4 out of 12 chance of getting a daisy. Now the second time around, they say picking a rose from the garden. Now we have to pick a rose from the garden. Now there were 3 roses in the garden, and since you have a daisy in your hand from the first time around, that doesn't affect how many roses there are in the garden. There's still 3 roses because you didn't pick the rose the first time. But how many flowers, how many total possibilities are there out of the garden if you've already picked a flower? There are only 11 possibilities. There were 12, but you picked a daisy out of that garden, so now there are only 11 flowers available for you to pick from. So picking a rose from the garden after you've already picked a daisy from the garden is a 3 out of 11 chance of getting a rose from that garden. Now, do you see how this 11 has been changed from the first selection? The first time around you picked a flower out of the garden and it changed this number. It changed the probability or the possibilities from 12 to 11. So the second selection is altered or changed by the fact that you already did the first selection, that you already picked a flower out of the garden one time. So this is going to be dependent. Now here's a one. Being dealt a king from a deck of cards, then replacing the king back into the deck, then being dealt another king from that same deck. Now this is a lot more simple than it sounds. What's going to happen is you're going to get dealt a king from a deck of cards. Now let's do our probability fraction. There's 52 cards in a deck, and there are 4 kings possible in that deck, and you are dealt one of the kings. But you put the king back into the deck of cards, they shuffled him again, and then they dealt you another king from the same deck of cards. Now, since you put the card back, you replaced the card back into the deck, there are still 52 cards in the deck because you're not holding on to that first king that you got. You put it back. You replaced it. So there are also 4 kings possible out of the deck because, again, you didn't hold on to that king, you put it back into the deck. So do you see how this second selection is unchanged by the first selection? It's still 52. The 52 didn't change because you put the king back. The 4 didn't change because you had put the king back. You replaced the king back into the deck before getting the second card dealt to you. So these events are independent of one another. They didn't change each other. They didn't affect each other. Now that brings us to our next point. Since you replaced the card back into the deck before taking your second selection, it turned it into an independent event. It didn't change, it didn't alter the second event. So that's what you call replacement. When you replace the first card back into the deck before choosing again, it makes it an independent event. It makes it, you're putting the deck back to like it was before you started. So therefore, your second selection is going to be exactly the same as your first selection. Now without replacement, if you didn't replace the card, you would hold that king in your hand, and then you would get a second card dealt to you. That, of course, would affect the second outcome, and that would be dependent. So the replacement, when you replace it back, it makes it independent. IND for independent. And without replacement, if you hold on to that card and you don't put it back into the deck before you get dealt another one, that's going to be dependent. Now here's a good example. With replacement, you're going to have, the first thing is you're going to have kings available as cards in the deck. With replacement, if you replace the first card back into the deck, now that king, remember our probability fraction we've been doing, that's 4 out of 52. That's a 4 out of 52 chance that you're going to get a king out of a deck of cards. And then the second event, you replace the cards, you replace the king back into the deck, so you still have 52 cards in the deck, and there are still 4 kings available for you to get dealt. Now see, that's not going to change, right? So that doesn't affect each other. But look at this. And if you want to get the probability for all of this happening, both of these happenings, you just multiply them together. But look, if you replace the deck, if you don't replace the deck or the king, your first selection is 4 out of 52. But your second selection, if you want a king, you're only going to have 3 kings possible in that deck because you're holding on to the first king. And there's only going to be 51 cards in that deck because you're holding on to one of them. There's not 52 anymore. And so when you go to multiply these together to get the probabilities of both of these, the answers are going to be different. So that's how replacement and dependent and independent events affect your math when you're doing probabilities.